Hey, welcome back, you guys. Your favorite technical math class. We're going to take a look at linear inequality. So we've got this less than symbol, or less than or equal to, which includes the value. We got your greater than, we got the greater than or equal to. I always remember those, less than, because on a number line, it points to the lesser values, those negative values. I remember the greater than symbol because it points to the greater positive values on a number line. That's how I remember those. Let's go ahead and look at this. Of course, we like to visually represent these number lines. So -3 is that. -3, let's go ahead and read that, is less than 1. And if you compare it on a number line, we got 1 right here, and you can see how -3 is less than. It's to the left of it, right? -3 is less than that 1. Number 2 there, -1. And -4. Is -1 less than -4? No, I actually screwed this up, so sorry about that. That should be -1 is actually greater than -4. Sorry about that. So you see the -1's greater than that -4, isn't it? All right, let's go ahead and graph some now. Let's graph these on a number line. X is less than 3, so all values, oops, how's it doing that? All values less than 3. So I put an open hole for less than, meaning I'm not including the 3, but I'm including all values less than 3. So for example, the 2, right? 2 is less than 3. The 1 is less than 3. 0 is less than 3. All those numbers less than 3 are part of my solution set, right? But is 3 less than 3? No. That's why it's an open hole, because it's not including 3 as a solution, right? Now let's do x is less than or equal to 3. Now we're going to do it closed, meaning I include the 3 as part of my solution set. All values less than or equal to 3. So now is 3 included? Is 3 less than or equal to 3? You say, you bet it is. That's true. All right, so 3 is a solution. So is 2, so is 1, so is 0, and down the line, right? Less than or equal to. So go ahead, and this would be a good time to pause it and have this be a you try it problem. Draw x being greater than -2. All right, you should have had your arrow open at -2 and greater than. X is greater than -2. So your solution set is all values greater than -2. Now let's go ahead and solve inequalities in one variable. This is just like with equations. The only difference is you got to flip the sense of the inequality whenever you multiply or divide by a negative. That's the one difference you got to remember. Everything else is the same. So let's go ahead and solve for x here. Subtract 3 on both sides. And now notice I have to divide by -5. So that's where the alarms go off. Ding, ding, ding. I divided by a negative value. So I've got to change the sense of the inequality. So that switches right there. Instead of greater than or equal to, it switches to less than or equal to. And then I do 10 divided by -5, I get -2. If I don't change the sense of the inequality, I'll get the wrong solution set. That's why we have to flip that. Okay, anytime you divide or multiply both sides of an inequality by a negative number, you got to switch it or you'll have the wrong solution set. Okay? So we graph that, less than or equal to -2. So it's going to be closed or equal to and less than. And whenever you graph it, make sure that your value x is on that left-hand side. You cannot graph that thing if it's on the right-hand side. Let me give you an example. Let's do this next one here. I subtract 2 first. So I have -18 less than 6x. I divide both sides by 6. Now that's a positive number, so I don't have to switch the sense of the inequality. But don't graph it right here. You'll probably graph it wrong. You got to have the x on the left-hand side. So think about like putting this on a popsicle stick and spinning it kind of thing. Okay. You want to switch their sides, which means that's also when you switch the sense of the inequality. Now read it. X is greater than -3. X is greater than -3. So what happens is if students don't get it on the right-hand side, a lot of the time they'll try to graph that and they'll do it the wrong way, right? So that's what we're trying to avoid. So get your X on that left-hand side before you read it and graph it. Making sure that X is on the left-hand side with inequalities, okay? So similar here with that 6 less than or equal to X over 2 plus 8. We're going to go ahead and we're going to subtract 8 both sides. Now we're solving for X. We're going to multiply both sides by 2. Now that's a positive 2, so I don't switch the sense of the inequality yet. But I've got the X on the wrong side. So now I flip it, put it over here, negative over there, which means I got to switch the sense of the inequality as well. So X is greater than or equal to -4. Greater than or equal to -4. Okay, this next one here, we've got a 3x and a 7x. So again, I want to get the X on that left-hand side. So I'm going to go ahead and subtract my 7x. So I make sure that my x's are on that left-hand side. Now subtract 6 on both sides. And now I divide by a -4. And hopefully you're like, oh, I divided by a negative. I've got to flip that. Negative over a negative is a positive 7/4. So X is greater than 7/4. In other words, that's 1 3/4. Same thing, right? 1.75. X is greater than, so here's 7/4 right there. It's greater than 1 3/4. All right? 8/4 is 2. 7/4 is left fourth there. All right, now lastly, this section is we'll look at some compound inequalities. Okay, this is an example of a compound inequality. And it's made up of two statements. Let me start up here with the top right here. X plus 4, whoops, sorry. I'm going to read it like that, except I'm going to turn it around. X plus 4 is greater than -1. And, because I want to read it with that X on that left-hand side. And now I'm going to read that side. X plus 4 is less than 1. That's what that statement means. Okay? It has two inequalities in one, joined by the statement and. And means both have to be true. There must be an X value that satisfies both of those statements. And there's a series of X values that satisfy both of those statements. Okay, so how do you solve those? Well, you can solve it all at once. And so let's do this first one here. Or you know what? We'll solve this one that we just had. X plus 4 less than 1. So we're going to subtract 4. If I subtract 4 on that side of the inequality, I got to do it over here. But remember, there's two sides of this inequality. So I got to do it to all sides of the inequality. So I get -5 less than x less than 1. So x is greater than -5. So again, you actually read that part the other way around. You read it that way. And then I read this part. X is less than 1. So it's all values between 1 and -5. I'm less than 1 and I'm greater than -5. So it's just those values between them. So my actual graph is just between them like that. I'm less than 1 and I'm greater than -5. So this part right up here in yellow, that's key, right? That shows you what that graph's going to look like. X is smashed between 1 and -5. And they're open on 1 and it's open on the -5. So let's do this first example. We're going to subtract 1 on all sides. And I'm going to divide by 2. So my graph will be less than or equal to 1, less than or equal to, so I'm less than or equal to 1, but I'm, oops, that's supposed to just be a greater than right there, sorry. And I'm greater than -2, greater than -2, so that's it. All right, so it's between -2 and 1. Notice the 1 has the line underneath it, so it should be filled in. Notice the inequality next to the -2 there is open. All right, this next one you got to be a little careful with. Notice that we'll subtract 6 first. And then notice we're dividing by a negative. And so we got to flip all these inequalities. So that'll go the other way now. That'll go the other way. But now notice my 10 is on the left, my 4 is on the right. You need to have it going from lowest to highest. So it's kind of like putting this on a popsicle stick, if you can imagine, and spinning it again. So 4 ends up being there along with its sign, and the 10 over there along with its sign. So you've got to flip that whole thing around so that you graph that thing correctly. So the graph would then be less than or equal to 10, greater than 4. All right. X is greater than 4 and less than or equal to 10. So just be careful on those when you're solving them. Thanks so much for watching. See you next time.